All right, let's take a look at some more of these expressions with trig stuff in it and see if we can simplify. In fact, why don't I give you an opportunity to try these right now with some interactive moments, see if you can actually simplify it and see what you get. These are actually really fun, so it's sort of worth trying. And then I'll do it, and you can see if I'm right. So how about 1 plus tangent x divided by 1 plus cotangent x. And I'll just give you a teeny little bit of a hint here. Well, maybe it won't help you at all, by the way. But I'll tell you how I always think about these. I always think about these by first converting everything to sines and cosines, seeing if I can clean things up, and then using identities about sines and cosines. Give this a try right now and see how you can do. All right, well, let's see how I can do. Again, I would convert everything to sines and cosines. So I'd write 1 plus, and instead of tangent, I'd write sine x over cosine x. That's the same thing as tangent. And then 1 plus cotangent. Well, cotangent is just 1 over the reciprocal of tangent, so it's just going to be the reciprocal of this. So it's going to be cosine x over sine x. Now, you may think, well, gee, I could just cancel those 1's away, and then somehow these get canceled away and stuff. Well, don't make that mistake. In fact, that's one of my classic mistakes here. Remember, it's actually mistake number 3. Classic mistake number 3.
Number 3.
That's right, it's the canceling mistake. You have to cancel factors, not sort of individual terms like this. So always be careful about that. What I'm going to do instead is get a common denominator here. This is what? Well, 1 is actually cosine x divided by cosine x. Cosine x over itself. If I have a common bottom then, cosine over cosine, I would see on the top cosine x plus sine x, and that would be all over that bottom, cosine x. So that's just the top. That's just the top, getting a common denominator. Now if I get a common denominator on the bottom, I'd multiply top and bottom here by sine x. So I'd see sine x over sine x. And if I add, I'd see sine x plus cosine x plus cosine x, all divided by the common bottom, sine x. So now how do I deal with this? Well, remember, I invert and multiply the bottom, so I go whoop, and so what would I see? Now we have to use parentheses here to be careful. On the top I see, let me write the sign first. I see sine x plus cosine x. I just flipped the order of that addition. But then when I flip this, look what happens. The sign gets on top, so I've got to multiply everything through. Look how I put the parentheses here. Those parentheses are crucial. Everything through by the sign. And then what do I have on the bottom? On the bottom, I'm going to have this thing, because look what happens when I flip this. Whoop! It's going to go on the bottom. So I see parentheses sine x plus cosine x, that sounds familiar, times cosine x, that cosine x right down there. When I flipped it, that cosine x remains. Well, now you can see these guys cancel. And what am I left with? I'm left with sine x over cosine x, but that has a name. It's called tangent. So in fact, this complicated thing actually reduces down to tangent x. Hope you got that one right. It's pretty cool. Just by changing everything to sines and cosines and doing a little bit of arithmetic and algebra, you can actually figure out exactly what this is. Let's try another one. And again, I'll give you a shot to do this first interactively. So secant squared theta minus tangent squared theta over cosine squared theta plus sine squared theta. I want you to simplify this as much as possible using the basic facts that you know and the identities. Give this a try right now. See how you do. Well, okay, there's a few ways of thinking about this. You can convert everything to sines and cosines, which means make this a 1 over cosine squared, and make this a sine squared over cosine squared, and then seeing what happens. That will actually work, and you can try that. Or you might remember that secant squared, this is one of the Pythagorean identities, secant squared theta equals tangent squared theta plus 1. So if I use that right here, I'll replace this by what it equals, which is tangent squared theta plus 1. That piece there is just this piece right here. That is a Pythagorean identity. That just comes from the Pythagorean theorem. Here it is. Secant squared equals 1 plus tangent squared. And we just got that by taking this thing here and dividing through by cosine squared. Anyway, we have that, but don't forget this term, minus tan squared theta, all divided by, but what's cosine squared theta plus sine squared theta? That has a name. Cosine squared theta plus sine squared theta always equals 1. So in fact, this is just 1, again, by that famous identity. So the bottom just sort of has completely evaporated of anything important, and I have tangent squared theta minus tangent squared theta. In fact, those add to give 0. And I'm left with 1 over 1, which is 1. So in fact, this really complicated looking thing, oh, it's so complicated, turns out just to be the number 1 in disguise. Isn't that amazing? That was real fun. I wonder if you got 1 and sort of got nervous and said, oh, gee, it can't be 1. It has to have thetas in it. It's okay. It's okay. Don't panic. Just be really careful with the arithmetic and with knowing the identities, and you can actually simplify things sometimes dramatically. All right, how about one more for the road? Your last shot here. Secant theta over sine theta minus sine theta over cosine theta. See how much you can simplify this expression. Give it a try right now. Well, what I would do is get a common denominator here. So I'm going to multiply top and bottom here by cosine and top and bottom here by sine. Let's see what that gives me. Top and bottom here by cosine, I'd see cosine times theta, don't forget the theta, times secant theta over, and then I have sine theta times cosine theta, minus, and then I multiply top and bottom here by sine, top and bottom. So I'd see a sine theta and a sine theta multiplied together is a sine squared theta. And the bottom I have sine theta times cosine theta. Well, can I simplify this a little bit? Well, now I have the same bottom, so I can just add the tops. By the way, what is this right here? That looks pretty complicated. Can I simplify that? Well, let's think about it. What is secant theta? Secant theta is just 1 over cosine theta. So if I multiply that by cosine theta, what's cosine theta times 1 over cosine theta? It's just 1. So in fact, this top is just 1. So that's just 1 on top, but minus the sine squared theta, all divided by sine theta cosine theta. What's 1 minus sine squared theta? Well, going back to that famous Pythagorean identity, if I take the sine squared theta and move it to this side, I'll see a 1 minus sine squared theta, and that would equal cosine squared theta. So cosine squared theta is 1 minus sine squared theta. So 1 minus sine squared theta, well, that's a very fancy way of just saying cosine squared theta over sine theta cosine theta. And now I can cancel out some of the cosines. I have 2 cosine factors on top, 1 on the bottom. So as long as they're not 0, I can cancel them away, and I just see cosine theta over sine theta. And cosine theta over sine theta has a name. It's not quite tangent. That's sine over cosine. It's the flip, so it must be cotangent. So cotangent theta. So this complicated-looking difference of fractions, after you get a common denominator, you use identities everywhere, turns out just to be the same thing as cotangent theta. Pretty cool. Anyway, I hope you get a sense of the possibilities we have to take really complicated expressions and sort of water them down to an equivalent but much simpler expression to work with. These things will be really valuable when we start to see if certain identities using trig things really hold in general or not. Anyway, I'll see you up next, and we'll take a look at more identities. I hope you enjoyed these things, by the way. I just think they're a gas. I'll see you soon. Bye.